Welcome everybody. Welcome to Techno Day 2022. This is Aastha Sahni, and I'm going to speak on intelligent threat handling using machine learning. And before that, let's know a little bit about me. So I'm currently the lead cybersecurity instructor at Flatiron School, New York. I'm also the founder and board chair at Breaking Barriers Women in Cybersecurity Foundation. I'm also the founder of Cyber Preserve, which is a cybersecurity mentorship initiative and also a YouTube channel. And I'm also the committee member of OWASP Women in AppSec, which is OWASP WIA. Let's look at the agenda for today. The agenda might look very long, but it's not, because we are going to cover a couple of topics, not so much in detail because the topic is around cybersecurity, threat handling, and then machine learning, big data. But it's important to understand the integration of both the parts, like both the areas and how they are going to work together. So that's why the agenda might look long, but it won't be, because we are going to cover the baby steps and then we are going to move towards the actual integration of machine learning with cybersecurity and threat handling. So first of all, we are going to learn a little bit about what is cybersecurity, what is big data, what are the challenges between cybersecurity and big data, then machine learning to the rescue. So when we talk about machine learning to the rescue, we are going to cover what is machine learning, types, classifications, Python as well, because Python also plays a very important role in machine learning and cybersecurity operations too. We're also going to cover some use cases where these things can be applied and are already being applied. And then finally, some ground truths and conclusions. So, what is cybersecurity? Cybersecurity is something that all of us kind of know because we hear about cyber attacks, phishing, scams. In your language, you learn about some cyber fraud. So, cybersecurity is actually an area which concerns the understanding of cyber attack and its corresponding defensive measures. So, we as cybersecurity professionals, we work towards identifying those threats, identify them before time, prevent them in real time so that all of us can build a safe, smart world. So, under cybersecurity, we have three important pillars: confidentiality, integrity, and availability. So, these are the three important pillars of cybersecurity. So, what does confidentiality means? Confidentiality means, let's say, there is an information, there is a file, let's say, which needs to be shared only among few people, not to the whole public. So, it is confidential data. It needs to be shared only between specific parties, and nobody else should be able to access that data. Integrity means whatever data that we share over online, okay, that data should not be tampered. Let's say you wrote an email to your friend and they received an email, but which has the body which contains some completely different content that you didn't send at all. So integrity means nobody can tamper your information when you are sharing it online. And availability means very simple: all social media sites, you are entitled to access Google, you are entitled to access Facebook. So availability means whatever our internet that is accessible to the public should be available. Similarly, available in privacy, in private terms, also means like there are specific database or files in your office that you can access and they are available all the time. So they should be available to you when you need. So all these three pointers, they become the three pillars of cybersecurity. Next is big data, because we are definitely going to talk about threat handling, machine learning, and that's part of. So threat handling is part of cybersecurity, big data. Under big data, machine learning is part of big data, handling big data. It has a huge role to play there. But what is big data? Big data is, if you want to understand in lay terms, in early 2000, when we didn't have social media, not much of internet. So internet must have come already. Yes, it started off around in 1980s, a little bit of it, and then we grew from initial let's say expansion of internet to let's HTTP and web 2.0 that we use right now. So before that, when the usage of internet was very limited, what were we doing? We were in our real time. We were not we were not exchanging information over the internet. But over the years, since 2005 6, when your social medias and the internet intervention of humans became more prominent, we started to share more data. Companies, they become prominent. Their databases, rather than become physical, they become virtual. So when all these changes, they move to online, what happened? Actually, big data happened. And with big data, what does this mean? It means that data that contains a lot of variety, because different social media, and not only social media is an example for us as a general public, but we have a lot of data which is flowing over the internet in the form of cloud. Then we have company websites, they are storing data. So a lot of information is being sent and received, and that information is of wide amount of variety. That information has a lot of velocity, it has a lot of volume, and it has a value to us because we use that data for specific purposes. Now, that big data is structured, unstructured, and semi-structured. What does structured, unstructured, and semi-structured means? Structured means, let's say we have a table, we have row and columns. That become a structured form of data, like defined format. Unstructured is all the data that's flowing over internet, your Twitter, your Facebook, your LinkedIn, and whatnot. The data, if you try to extract that data, okay, there are ways to extract that data, of course. So when you extract that data or you look at that data, let's say, like how to look at that information is completely unstructured. So the tweet that you're looking at Twitter, you might not like when you extract, because it's just raw data. So unstructured data is just raw data without any structure or format. And semi-structured is like your email. Your email has a body which is completely unpredictable because anybody can write anything in the body, but email has a little bit structure, like to whom you are sending, then what is the subject and the body. So it has certain structure, but still semi structured, not completely structured information. So big data is the anticipation of things like internet of things, mobile apps, company data, and whatnot. And it's so large, it's so huge. We are receiving petabytes or even more than that of data per second. That's big data. Now, what are the challenges? Like, where does cybersecurity and big data they actually meet? Like, why are they even meeting, and what is their relation? So the whole point is, as part of cybersecurity, okay, what we have seen is we have seen an increasing number of malware executables. So since 2010, there were like less than 5 million. In 2012, they became like 100 million. And by 2019, they were like 936 million. So in fact, the data which concerns security, which concerns management. So, in fact, let's say there are antivirus solutions. How many viruses they can detect and how many viruses may not be detected? Because there is a lot of data coming in. The data is evolving so fast. Even attacker is evolving threats at a very high speed that as cybersecurity professionals, it becomes our first or important duty to proactively look for threats, prevent threats, identify threats. Now, what's happening is your general data is increasing, and that like the data which is increasing over the internet is valuable too. It needs to be protected. It needs to be protected wherever it is stored online, because we have to think about privacy, security, and whatnot. You don't want your personal information to be exposed to some attackers, not at all. We live in the world of e-commerce. We don't want our credit card information and all should be exposed. No, we don't want that. So definitely, with increase in number of data, with increase in number of internet for the purpose of day-to-day life, like for example payments and whatnot, we're using internet all the time. So less than being physical, we are online, we are digital identities. So we have to we have to preserve these identities, we have to monitor their data, we have to prevent attacks. And that's how big data and cybersecurity comes together. When we talk about cyber means online, and security means we have to secure this online data. It has been estimated that a data breach can cost 8.9 millions USD for United States and 3.9 millions USD on an average. That's a big number. Also, companies like Frost and Sullivan predicts that the growing gap between available qualified cybersecurity professionals and unfulfilled positions will reach by 1.8 million by 2022. So there's a huge gap, and we really need to address this gap. And how we can address this gap? This is where your machine learning comes to the rescue. Machine learning, actually, why it comes to the rescue is because with huge amount of data, you have to handle that data. So let's say 20 years ago you were handling like 20 data requests, or let's say you were working on, let's say, data, even though on physical or a little bit online, you did not request so many alerts, so many projects, so much data that you have to identify like what's right and what's wrong and what needs to be taken care immediately. So machine learning can enable human to focus on those tasks that are more valuable to their roles. So there are a lot of tasks which are like filtering data or removing unwanted data in case of specifically big data. So all those steps which require a lot of manual work, and where we can bring automation so that human beings can focus on the core roles for what they are hired for. That is where machine learning comes into picture. Machine learning is not there to replace humans from their jobs. Machine learning is there to make your jobs easier. Automation is going to make you free from your routine redundant tasks that are no longer interesting to you and can save a lot of time. You can focus on more valuable tasks. But the whole point is, what is actually machine learning? Because we have been hearing a lot about AI and machine learning. Are they same? We have also heard a term known as deep learning. Are they also same? No. So what's the reality? Artificial intelligence is a broader concept under which machine learning and deep learning comes actually. And artificial intelligence is where we can like design concepts of machine, which where machines can carry out tasks in a human way. That's artificial intelligence. Under that, machine learning and deep learning comes into picture. What is machine learning? Machine learning is the subset of your artificial intelligence where machine learns to predict results based on data provided. And under machine learning, we have two forms, which you can see right now on the slides: supervised and unsupervised. And we are going to discuss that in the next slide. What is deep learning? Deep learning is further part of your machine learning, and it is based on neurons that we have in our brains. It's like the inspiration has been taken from that. Now, types of machine learning. So one is supervised machine learning, another is unsupervised machine learning. And in order to understand that, let's again pick real-time example. As a human, as a child, I'm not like literally generalizing it to a human, but let's say as a child, when we were small, we learned English, we learned alphabets. Okay. And when we started to learn alphabets, we passed one class to another class to another class to another class till the time we were in high school, senior school, and whatnot. So during this time, we learned and we memorized. So today, if you are, let's say, 18 years old, you're not learning A for apple and B for ball because you learned it. So supervised learning is based on where there is an algorithm and you feed data, some training data, like compare this training data to your books from where you learn. So a training data is fed to the algorithm, and the algorithm memorizes that training data, learns how this is working, and then predicts results. Unsupervised is where a person says, I don't need any help. I'm going to learn myself. So unsupervised learning is where the machine learning algorithm learns by its own experience. It identifies hidden patterns. It works with its own way of identifying features from your data and then predict results. Under supervised machine learning, there are three major algorithms that we use. One is logical regression, another one is decision trees, and the third one is XGBoost. And there are, in fact, more than this. There are more than these supervised machine learning algorithms. But the whole point is they themselves are another level course that we need to probably do and work research on. But the whole point is these are the major machine learning algorithms that we use in security operations. And there are many others, but this is just an example. Another term that we often use in machine learning is classify. What is classify? Okay. So as I was talking about supervised machine learning and I was talking about training data. So that's what's happening here in classify. So let's say I have an example of sentences, positive and negative sentences. And let's say a sentence is, it's a beautiful day. It's a beautiful day is a positive sentence. And then I'm a little sad today. Today was not a good day for me. So when these terms, sad, not, disappointed, gloomy, these terms comes, it means negative. But when it's like beautiful, happy, joy, it comes positive. So if we have a training data means, let's say I have a list of sentences and I have classified them like beautiful day, positive, not feeling good, negative. So if I am providing a data to machine which has data and its classification means categorizing positive, negative. If I'm doing so, the machine is learning from it, and next time if I feed normal data without any classification, it will predict through that learning. And that's what classification means. So in this example, in this picture, if you can see, I'm providing some features, I'm providing some labels. Labels is where yes, positive, negative, yes, no, these labels to your data. The machine learning learns from it. When it learns from it, then it tries to predict. So the second level is prediction, where you just feed data and then it will predict results. The next one is unsupervised. And unsupervised, as I said, it says, I want to learn on my own. So one of the examples of unsupervised is clustering. What does clustering means? If you look at this diagram, we have some black dot clustered, we have some right dots clustered. It means similar data samples are grouped together. How does this imply in cybersecurity? Very good. It can be a very good question that you might be thinking as you see this session. So what happens is, let's say somebody is trying to brute force into your system, means trying to pass as many usernames as password as they know, as they have got, and they're just trying to like random username and password, and they want to get into your system, like what could be the possible name, what could be the possible password. Those number of attempts, when they try, they will be failing, and there would be one, maybe one that attempt where they might pass. But all the attempts that a particular attacker is failing comes under failed authentication, because when you log into your system, you authenticate yourself, you verify who you are. So when they are not able to do so, these are all failures. So all the failures will cluster towards one, maybe black or maybe red. Here in this picture, it can signify that, like we are making a group and cluster, we are separating data with the help of clusters. That's what clustering means. Another example of clustering is, look at the sample here of different types of potatoes and how they have been segregated based on their group and color. So what type of potato is alike, or they are of the same form, they have been put together, and the rest of them have been put in the second other groups. Then comes your machine learning, deep learning approach under machine learning. Now, deep learning is where we are utilizing the approach of neurons in our brains. It is said that in your brain we have like there are multiple neurons, and when a message is passed to your brain, it goes to first neuron, then that first neuron pass some message to the other, to other, to other, to other, to other, and till the last neuron, where a final answer, like a final information, is saved or understood. This is exactly what's happening in deep learning. We have, if you look at the diagram, we have an input layer, we have an output layer, and then we have in between a hidden layer. So input layer is feeding some data. Okay, take the data, take the data. The internal layers, which can be many, they're passing learning from that data, and finally we have a final output. A typical artificial neural network, an example of that, it's where, as I said, there are neurons which are transferring information. If you look at this diagram, we have an input information, then we have process, like each neuron processes information and then provides a final output. So this is what exactly happens in our brain when we process information. And deep learning in itself, it's a very active area. It's still being researched, it's still being understood, it's still being researched for the purpose of how we can use it for various purposes and futures, and how it can be used. Then Python and data analytics. So how does Python helps here, and what is it Python doing? So first of all, Python is a high level programming language. For many of you who don't know what Python is, it's a high level programming language like Java, if you have heard of. So Python is also one of the very famous language used. The purpose of using Python is, like, we use for web development, we use for scripting and automation, we use it for data visualization and analytics, we use it for AI and machine learning. So Python has a huge scope, and it is used in a variety of ways in cybersecurity. One of the examples of using Python is, here's an example of data visualization. So on the right hand side, here is a short code, and on the left hand side, there is a output of that code. Now what's happening is, if you look at the right hand side code, we are importing pandas. Pandas is one of the modules or libraries in Python, and using pandas, what we have done is, we had some data in Excel sheet. Okay, we have transformed that data, which is total number of tweet count and number of traffic areas, and we have transformed it into a visualization. So the scope of using Python is such huge in data science and cybersecurity, especially in cybersecurity in the form of machine learning, because there are a variety of Python libraries. Like one of them I showed, like pandas. Then there is NumPy. sklearn is specifically used where we have Python the sklearn is used for implementing different types of machine learning algorithms. Then we have PE files, then we have ngrams. So there are variety of libraries in Pythons which are specifically used for the purpose of machine learning. And of course, using this, we can implement a variety of operations for cybersecurity in terms of, let's say, automation and in terms of predicting threats. Now, let's look at how all of this machine learning concepts, they are applicable in cybersecurity and threat handling basically. So first of all, recognizing threats, predicting threats, classified threat patterns. We can also utilize machine learning for the purpose of application code review, risk assessment, identification. On the whole purpose is of detection, prediction, and optimization. Then we have some attack scenarios where we can implement machine learning. So let's say for every file sent through the network, through your network, does it contain any malware? For every login attempt, has someone's password has been compromised? For every email received, is it a phishing attempt? So we have to predict, and we can predict based on patterns, and that is where machine learning can help us. Now, impact of machine learning on cybersecurity. So one of the major impacts which we can create is machine learning applies fuzzy matching, that is clustering, that I have explained in the previous slides. We are grouping. Automatic selection is you get data, you automatically understand that data, classify, create features so that you can understand what the data is, so that you can further classify that data into specific pattern. Adaptive response, that is also an active area in machine learning, where what we are trying to do is so that the machine classification, like your malware, for example, one of the example here discussed is malware analysis, like how to analyze malwares or predict malware. So adaptive response is where when data is fed, and that data, let's say, was not part of training data, it's not similar to what we have provided in training data at all, and machine should be able to learn, adapt to the changing, evolving threats and the related data. That becomes an important part here. Then is when we were talking about malware, how to get training data for malware. There are variety of websites, variety of platforms from where we can get malware data sets. Let's say we have Kaggle, we have virus total, and we have malware traffic analysis. So there are multiple sites, multiple platforms which are having data sets or which are utilizing malware analysis as part of their application, where you can find data sets for training your machines, training your machine algorithms. The overall problem is that whatever data, training data that you're working with, that data can be biased. It has majority of data of specific type of malware, because we're taking the example of malware. So it can have data from specific type of malware and then completely does not have any data about any different type of malware. So there can be biasing in your data. There can be majority and minority classes. The labels that we are providing, basically when I say there are 2 3 sentences and I'm labeling them as positive and negative, so those labels are not properly done. Missing data, so let's say our training data completely misses out on something like a specific type of data which was very important for prediction, and it's completely missing. So there are some problems with data handling as well. Now let's look at some of the ground truths. The ground truths are, first of all, there are no real standard for data sets yet, especially in case of cybersecurity for identifying threats and malware. We don't have a standard. Like companies might be using data sets from specific applications like I've shown in my previous slide, but the whole problem is there is no standard defined. Also, deep learning algorithms, which is unsupervised, like clustering, deep learning, they take time to learn because they're learning by themselves. They are unsupervised. And supervised learning models, they require retraining, because let's say I use a training data set and through that algorithm was predicting, let's say, to a very high accuracy. But then when completely a new data came, it did not, like, the adaptive response was less. And at the same time, let's say there was a missing data and now we are feeding that data. So it requires retraining from time to time when accuracy starts to go down. So supervised machine learning algorithms, they require retraining. Now, what's the bottom line? The bottom line is adapting to evolving nature of cyber threat landscape more efficiently is the key to future detection and prediction methods. And that's how we are going to utilize machine learning more for the purpose of threat handling, both in the case of detection, prevention, and proactive detection as well, where you are like more active in such a way that you are performing all the steps of detection even before knowing if something is right or wrong. And thank you for this session, and thank you for having me today. If you would like to read, these are some of the references from my session. So if you would like to reach out to me, you can reach out to me at Aastha, Aastha, at the rate bbwic.com. And thank you so much for having me today. And it's a special occasion. It's International Women's Day. So I wish all the women out there a very happy International Women's Day. I hope you continue to grow and we continue to bring a strong community out there across the world. And thank you again for having me.